Hello. So we are going to do the notes for comparing and ordering numbers, rational numbers. So we're going to start out by just reviewing some different types of numbers so that you then will be able to order them. We're going to look at scientific notation. This is something you should have learned last year, so just a review. When you have a number in scientific notation, we have a coefficient, okay, whatever is being multiplied. We have the base, which is always going to be base 10, and then we have an exponent, which can be positive or negative. You will notice that a positive exponent gives us a big number, and a negative exponent gives us a small number. The exponent is going to show you how far to move the decimal. So if it's a positive exponent, it means to move the decimal point right. If it is a negative exponent, it means to move the decimal left. The coefficient is always going to be a number between 1 and 9. So you're never going to have a number before the decimal that is more than 9. You can't have 10 point something. That's not written correctly in scientific notation. The base is always going to be 10. Negative exponents denote very small numbers. Okay, so the reason we do scientific notation is because no one wants to write a ton of zeros, and nobody wants to write really, really big numbers. The bigger the number is, the more digits, the more likely you are to make a mistake. So this helps scientists be more accurate. So for example, this 2.6 times 10 to the negative third means I'm moving this decimal right here 3 spaces to the left, which is going to give me, okay, so my decimal was right here. I moved it 1, 2, 3 spaces to the left. And now I've got a new decimal point right there, 3 spaces. So let's try this one. This one says I'm moving 5 spaces to the left. So I could do 1, 2, 3, 4, 5. Those become zeros. Look at all those zeros. So I was here, 1, 2, 3, 4, 5. Okay, you can put a 0 before the decimal point. You do not have to. This one I'm going to move 2, 1, 2. This one wants to move 6, so that's a lot. So let's get my zeros here. I was here, 1, 2, 3, 4, 5, 6. Let's go the other way. So when we put it into scientific notation, I'm going to always start from the left like you read a number, and I'm going to put a wall after the first number that is not a 0. So going from the left, first number that's not a 0 is a 1. I'm going to put a second wall on the decimal point. Okay, so this tells me I'm going to have 1.463 times 10. Now, number in between my walls, however many digits that is, that's my exponent. So this is negative 1. So let's do the next one. From the left, first number that's not a 0 is 2, so I'm putting my decimal there, so 2.9 times 10. Second wall goes on the decimal point, and I'm going to count in between. 1, 2, 3. So this exponent is negative 3. Again, first number that's not a 0, that's my 4. So 4.01 times 10. Another wall right here. 1, 2, 3. So this is to the negative third power as well. Let's do some positives. So positive exponents denote very large numbers. So 2.0 times 10 to the 7th. I'm moving the decimal 7 places to the right. Okay, so I had 2.0. So 1, 2, 3, 4, 5, 6, 7. So I was here. 1, 2, 3, 4, 5, 6, 7. Let's try the next one. I'm moving 4 spaces to the right. 1, 2, 3, 4. Any space that doesn't have a number becomes a 0. So 5, 3, 6, and I've got 2 more spaces. This one's moving 2. 1, 2. 800. And then I've still got 0, 2, 1. This one's moving 3. 1, 2, 3. All right. Now when we do the walls on this one, we're going to do the same thing. So starting from the left, first number that's not a 0 right here. So I've got 6.8985 times 10. Second wall is going to go where the decimal point is. The decimal on a whole number is always at the end. I'm going to count in between. And that's 4, so this is to the 4th power. Next one, first number from the left that's not a 0 is the 3 there, so 3.2 times 10. Second one's at the end. Let's count. 1, 2, 3, 4, 5, 6, 7. So this is to the 7th power. Next one, first number that is not a 0 is the 5. Next one is at the end there. 1, 2, 3, 4, 5. 5th power. The exponent determines the number of spaces you move the decimal. All right, let's flip over here. All right, so let's talk about some conversions. When you order rational numbers, you always want to order decimals. All right, so first you got to make everything a decimal. Fraction to decimal, pretty easy. You may use a calculator for all of these things. Fraction to decimal, you just divide, top divided by bottom. So we're going to do the top number, we're going to divide it by the bottom. Okay, so 7/10, or 7 divided by 10 is 0.7. 3/8, we're doing 3 divided by 8. And 2/3, we're doing 2 divided by 3, which is equal to 0.66, repeating. Let's talk percents to decimals. If you have a percentage, you're going to move 2 spaces to the left, or divide by 100. So here's my decimal. Move 2 places to the left. This is 0.32. Decimal here, move 2 places to the left, 2.45. Decimal here, move 2 places to the left, 0.2. Decimals to percentages, we're going to do the opposite. So now I'm moving 2 places to the right. So this is 45%. 2 places to the right, this is 150%. 2 places to the right, this is 87%. Decimals to fractions is the hardest, and because we're making everything into decimals, this is not something we necessarily need to work on. We want everything to be a decimal when you're doing stuff, so we're not going to do that one. All right, let's do some comparing. Just a reminder, this is the less than symbol. This is the greater than symbol. And this is the equal to. Okay, so really easy numbers. This one's bigger. It opens towards the bigger number, or it points to the smaller number. All right, now in order to compare and order fraction, decimal, percents, and other real numbers, everything needs to be converted to a decimal. Then some strategies are to stack them up, where you line up the decimal points, add zeros so they have the same number of digits, and then compare from the left digit first. So if I had I would add zeros here to make them the same size. Notice I've lined up my decimal points. Okay, if I'm going from greatest to least, I start from the left. 0, 0, 1. This is my biggest. Okay, they're both zeros. 3 and 2, 3 is bigger. And that's how we would do it. So these are pretty easy. We need to get some decimals here. Okay, so 12 sevenths versus 8 sixths. So 12 sevenths, 12 divided by 7 is 1.71. and 8 divided by 6 is 1.3. So I'm going to do a greater than sign here. Next one, 1.6 repeating versus 1.6. 1.6 repeating is bigger. Because if I added an extra digit here, this one would be a 6 and that one would be a 0. 4.2 times 10 to the negative second, I'm moving it over 2 times. So I'm going to have 0.042. So this one is smaller. And then my negatives, just be careful. The more negative it is, the smaller it is. So this one is more negative. That one is smaller. All right, last page. A little bit of vocab. Ascending means going up. So this is least to greatest. Okay, ascending the stairs, it's like going from small to big. That means descending is going down. Descending is going from greatest to least. Or going from big to small. All right, again, when we do these, we want to make everything a decimal first. So the negative square root of 36 is negative 6. 3.2 times 10 to the second, move it over 2 times. This is 320. 4.34 times 10 to the first, move it over once. This is 43.4. 125%, I'm going to move it 2 times to the left, 1.25. And negative 9 halves is going to give me negative 4.5. Now I have to read this, arrange the numbers from least to greatest. So I want the smallest number first, so I'm looking at negatives. Negative 6 is more negative than negative 4.5. So the negative square root of 36 goes first. Then negative 9 halves. We're always going to put them back in the original form. Now smallest here is 125%. Then I've got 4.34 times 10 to the first, and finally 3.2 times 10 to the second. 2 more. Let's get everything to decimals. This is already a decimal. This is negative 0.625. This is negative 2.6. And we've already got a decimal here. This time, make sure you're reading. We're going from biggest to smallest. So the biggest is going to be actually what looks like my smallest because these are negatives. So the biggest is actually this one, my negative 5/8. Then I've got negative 0.8. And then we've got negative 2.45 and negative 2 3/5. Last one. So 3 9/12 is 3.75. 13/4 is going to be 3.25. Move this over 2 times to get 3.12. Move this over 2 times to get 0.042. And pi is 3.14. It goes on forever. I'm just going to leave it there because we don't have anything that goes beyond there. I'm going in descending order, so that means I'm going from big to small. So my biggest here is 3.75, so 3 9/12. Then I've got 3.25, 13/4. Then I've got 3.4, pi. Then I've got 3.12, 312%. And finally, 4.2 times 10 to the negative seconds. That's all I've got for you on these notes.